Hello everyone, myself Dr. S. Krishna, working as Assistant Professor, Head of the Computer Science and Design Department in St. Martin's Engineering College. I welcome you all to online lecture. Today I am going to discuss about OSI reference point in computer networks. So OSI stands for Open System Interconnection. It has 7-layer approach. So all these layers are combinedly worked together to transmit the data from one device to another device over the internet. It's a reference model. So all these layers are work together to send the data from one place to another place. So coming to the layers, 7 layers. Starting layer is physical layer. The main responsibility of the physical layer is physical representation. And next layer is data link layer. The main responsibility of the data link layer is error control and flow control. And next layer is network layer. The main responsibility of the network layer is logical topology, routing, and path determination. And next one, transport layer. The main responsibility of the transport layer is end-to-end data transmission. Next layer is session layer. The main responsibility of the session layer is maintaining the sessions. And next layer is presentation layer. The main responsibility of the presentation layer is translation. So binary to ASCII, ASCII to binary, and encryption, decryption. These things are done in presentation layer. And next layer is application layer. The main responsibility of the application layer is SMTP, SNMP. So it acts as a stack of the application layer. We will see one by one. So first 3 layers also called as hardware layers, and top 3 layers also called as software layers. Coming to transport layer, that is also called as heart of the operating system. Coming to first layer, physical layer, the main responsibility of the physical layer is physical connection between the devices. Physical layer consists the information in the form of bits. This layer is responsible to transmitting these bits to next nodes. At receiver end, it receives the signals and converts it into bits, 0 bits. 0 bits are 1 bit. These bits are sent to the upper layers. Upper layer converts it as a frames. Again, frames will be converted into packets. This is sent to the upper layers. And next layer is, the functions of physical layer are bit synchronization, bit transmission rate, and physical topology and transmission mode. First one is bit synchronization. This physical layer provides clock by which sender and receiver bits are synchronized. And next functionality of physical layer is bit rate control. So this provides transmission rate, that is number of bits transmitted per the second. And next one is physical topology. So physical topology determines the structure of the network, how the devices are connected with each other. So it explains skeleton of the network. So coming to the various network topologies are
No. Clear.
various topologies are
Maximize. Right bigger one.
so topology. Coming to topologies, we have bus topology, star topology, mesh topology, and hybrid topology. Coming to first one, in bus topology, so all the devices are connected to backbone cable. All these devices are connected to the backbone cable. Here, advantage is less expensive. This topology is very less expensive. Coming to drawbacks, reconfiguration is difficult. And also, if cable fail, entire network communication fail. Coming to second one, star topology. In star topology, so all the devices are connected to the central node. This node also called as switch or hub. So advantages, so easy to configure. Coming to drawbacks, if switch fails, entire network communication fail. Next one is mesh topology. In mesh topology, there is each device having the end-to-end connections. Each device having the end-to-end connections. So this is very reliable topology. Coming to drawback, very expensive. This topology is very expensive. And next topology is hybrid topology. So hybrid topology is also called as the combination of bus and star topology.
So while shifting, talk something, sir. Don't look at it. Don't look at it. While shifting the pages, just
Okay. So next service of the physical layer is transmission mode. This defines how the data flows between sender and receiver. There we have three transmission modes. We have three transmission modes.
no, not allowed. Not allowed.
Three transmission modes. First one is simplex. In simplex, one-way communication is possible, either sender end or receiver end. The example is printer. And next transmission mode is R-duplex. In R-duplex, sender can allow to send the data and receiver also allowed to send the data, but one at a time. So example is walkie-talkie. The next one is full duplex. Next transmission mode is full duplex. In full duplex, sender and receiver allowed to transmit the data simultaneously. The example is telephone. So one more service of the physical layer is transmission medium. So medium means the cable which is used to transmit the data. There we have several transmission medias like twisted pair, coaxial cable and fiber optics. Twisted pair covers range up to 100 meters. Coming to optical fiber cable, it covers like kilometers. And next one, coaxial cable it connects multiple cities and multiple countries also. So the second layer of the OSI reference model is data link layer. The main responsibility of the data link layer is node to node message delivery, and also this layer ensures node to node error free message delivery. This layer accepts the data from upper layers. This data will be converted into frames. Coming to functions of the a data link layer are framing, physical addressing, error control. The first one is framing. So framing is a way, so sending the multiple bits to the receiver in meaningful way. The next one is physical addressing. So physical address is also nothing but MAC addresses. It's a 48-bit address. These addresses are used to identify the device in the local network. So this is vendor specific. So for each vendor there is a separate version of MAC addresses. So this is MAC addresses are embedded with network interface card. And next one is error control. Error control is a mechanism that coordinates the sender and receiver, and also it ensures error-free data transmission. So this is a process of identifying the error and detecting the errors and correcting the errors. Coming to error detection techniques, during the digital data transmission, the data may lost due to noise and signal interference. So by using error detection techniques, we can detect the errors and correct the errors. So first three techniques which determines and identifies the error, and last one Hamming code is for error correction. So parity check, checksum, cyclic redundant check, these three for error detection. First one, parity check. In parity check, so suppose I want to send the data frame like 10, 10, 101. In this frame, first I need to define the parity, whether it is even parity or odd parity. If it is even parity, I count the number of ones. If number of ones are odd, so append the 1 bit at position of the frame, and this frame will be sent to the receiver. At receiver end, also compute the number of bits. If number of bits even, data will be accepted. In this way, parity check will work. Next one is checksum. So checksum is a method to identify the error. So this is the data I want to send to the receiver without any errors. The first data will be divided into segments. All the segments are equal length. Here data is 4 segments. These 4 segments will be divided into length of 8. By using binary addition, perform the operation like so add is the first frame, second frame, third frame, and fourth frame. You will get the sum. By applying the ones complement, you will get the checksum generator. This generator will append with the original data. So these 4 are actual data. This is checksum generator. So finally, result will be 0 means data will be accepted. So next technique is error detection technique is CRC, cyclic redundancy check. In cyclic redundancy checks, by using modulo 2 binary operation with along key, we can compute the cyclic redundancy check. This is the data. 100, 100. This is a key. By using modulo 2 division, we will get the redundancy. So first we will see here key is 1101 is equals to XOR operation. In XOR operation, if both are 1 and zeros, we will get the zeros. Other case, the answer is 1. So if it is 110, remaining case 1. Like this, we can compute the XOR operation. We will get the redundancy. At receiver end, the redundant bits will be added to the original data, that is 001. By using key, applying XOR operation, you will get the result. If result all are 0 means the data will be accepted.
100% back.
Next one is Hamming code error correction. So widely used technique for error correction is Hamming code technique. In this, so I want to send the data 10110001. So in this, total number of bits are 7, total number of redundant bits are 4. That is depends upon the formula. A formula is 2 power r greater than or equals to m plus r plus 1. This is the formula to compute the redundancy bits. A total number of bits. After getting the redundancy bits, the total number of bits is 7 plus 4, 11. So where we append this redundancy bits. So redundancy bits will be added at the powers of 2, like 2 power 0, 2 power 1, 2 square and 2 cube. In these positions, so all redundancy bits will be added, like R1, R2, R3, R4. In remaining places, data will be added, like 1 0, 1 0, 0 and 1. Next, computing the parity for redundant bits. For this, check the one bit at least significant positions of R1. So for R1, so one bit in one position and third position and fifth position and seventh position and eighth position and 11th position. For R2, compute the check the where is one bit is present in second least position. For this R2 at position 2 and 3 and 6 and 7 and 10 and 11. In these positions, one is upbeat. Next, for computing the R3 parity, where one bit is present. 4, 5, 6, 7. For R4, 8, 9, 10, 11. So after this, so compute the parity. For R1, for make it as even parity, we need to add 0. For R2, we need to make it as even, add 1. Next one, for R3, add one bit. For R4, 0. So this is the redundancy bits or parity bits added at end of the message. This is sent to the receiver. At receiver end also perform the same operation. If any position change, this technique will help us to identify the error and correcting the errors. So next function of the data link layer is flow control. So flow control is a mechanism that coordinates sender and receiver transmitting the data at constant rate. There is a situation like sender is sending data at 100 Mbps speed and receiver can receive the data at 10 Mbps speed. So in this situation, data may lost or corrupted. To avoid this situation, we can use flow control techniques. So flow control technique. Mainly we have two techniques. So one is stop and wait protocol and second one is sliding window protocols. In stop and wait protocol, sender and receiver. So sender is allowed to send one frame at a time. After receiving the first frame, sender has to wait for the second frame. Acknowledge for the first frame. Before sending to the next frame, so sending as sender has to wait. This is a waiting period. It waits for the random amount of time, back of time. If acknowledgement is not received, same frame will be retransmitted. This is about stop and wait protocol. The drawback is more waiting time and less channel utilization. And next one is sliding window protocol. In sliding window protocol, at sender and receiver end, buffer will be maintained. So multiple frames allowed to send by the sender. Multiple frames is allowed to send the receiver. If any frame is lost, in go back end, the next consecutive frames are retransmitted. If it is selective repeat, only corrected frame only retransmitted. So this is about the flow control technique. The next one is next technique is access control. So access control is controlling the devices which are accessing the shared media over the internet. So these are the multiple access protocols. If we have dedicated connection between sender and receiver, so data link layer protocol is enough. If multiple devices are accessing the shared media, so there is a more chance to collision and crosstalk. To avoid this, we are using multiple access protocols. In multiple access protocols, Aloha, CSMA, CSMA-CD, and CSMA-CD. CSM Aloha coming to Aloha. In Aloha, again it divides into two protocols: slotted Aloha and pure Aloha. In slotted Aloha, if sender has the data, it sends to the receiver. It waits for the acknowledgement. If acknowledgement is not received, again after back of time, random amount of time, same frame will be retransmitted. In this way, collisions are reduced. So next one, pure Aloha. In pure Aloha, so time will be divided into slots. Sender is allowed to send at beginning of the slots, beginning of this time intervals. If any stations miss that chance, the station has to wait until the next beginning of the slot. The next one is CSMA, carrier sense multiple access protocol. In carrier sense multiple access protocol, before transmitting the data, so station node has to sense the channel, whether it is idle or busy. If transmission media or channel is idle, so sender is allowed to transmit the data. If channel is busy, so channel has to wait until channel becomes free. Again, CSMA divided into 4 transmission modes: one persistency and non-persistency and p-persistency. In one persistency, first before sending the data, sender has to listen the media. If media is free, sender is allowed to send the data. If not free, continuously sends the channel until channel becomes free. Coming to next one, P persistency. In P persistency, first listen the media. If media is free, so send the data. If it is not free, so not continuously send the channel. After random amount of time, packets will be transmitted. Next one, carrier sense multiple access by collision detection protocols. So in a network, in shared media, there are multiple devices are accessing the channel. It sends at particular points only, but not entire media. So it assumes like the transmission media is free, the channel is free. Then it starts the transmission to the next node. So other devices also assumes like media is free. So the reason is due to the propagation delay. So there might be data is collided. If data is collided, it sends the jamming signal to the receiver. Then it means stop the transmission. In this way, collision carrier sense and collision detection protocol will work. And next one is carrier sense and collision avoidance protocol. So collision avoidance. So by using various protocols like bit mapping, frame spacing, these are the protocols to collision avoidance. Next one, reservation, polling, token passing. These three protocols for controlled access protocol. In controlled access protocol, so one device acts as a primary and another are secondary devices. One is controller, remaining are slaves. The next one, channelization protocols. Entire media will be divided in terms of frequency, time, and code. Coming to next layer. Next layer is transport layer. This is the third layer. The main responsibility of the transport layer is logical addressing, routing, path determination. Path determination. It receives the data from upper layers and makes the data as packets. These packets, IP address, source IP address and destination IP address will be added. Coming to routing. So routing is the process of identifying the best optimal path through which packets are transmitted. So the best optimal path means based on some factors. Here factors are hop count and waiting time. These are the factors to decide the routing. Best routing algorithm. Next one is logical addressing. So logical addressing is nothing but IP addresses. So IP addresses are used to identify the device uniquely over the internet. Logical addresses again classified into two types, IPv4 and IPv6. So IPv4 is a 32-bit address and IPv6 is 128-bit address. So this is about network layer, and next layer is transport layer. The main responsibility of the transport layer is end-to-end message delivery. So mainly it provides two services, connection oriented and connectionless. For connection oriented, TCP protocol. For connectionless, UDP protocol is used. The next layer is session layer. So session layer is mainly used for establishing the session and maintaining the session and terminating the sessions. If there are file transmission is happening, there must be two connections established at sender side and receiver side. The next layer is presentation layer. The main responsibility of the presentation layer is translation. It converts the data upper layer. It receives the data from upper layers and converts it into required format. So functions of the presentation layer is translation, such as ASCII to binary, and next one encryption decryption by using symmetric cryptography algorithms. Data is encrypted and decrypted. And next one is compression. The number of bits reduced by using compression techniques. The last layer is application layer. The main responsibility of the application layer is it provides the window for the network services. So coming to services, file transmission, mail transmission, DHCP, DNS, all these things covered by this application layer. Now I am going to play video. So this is the video. It clearly shows how the packets are transmitted from sender to receiver. Okay. So these are the layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So first layer, it uses various protocols like DNS, DHCP, and SMTP, FTP. These are the protocols to transmit the data. And next layer is presentation layer. In this presentation layer, it deals with the encryption, decryption, compression, and conversion. And next layer is session layer. The session layer mainly deals with establishing the sessions between the sender and receiver. And next layer is transport layer. And transport layer, it mainly deals with connection oriented service and connectionless service. For connection oriented service, it uses transmission control protocol. It's a very reliable protocol. The header size is 20 bytes and very secure protocol. It uses efficient error techniques and detection techniques. So this is about today's topic. Thank you so much. Thank you so much all.